Alright, welcome back, Generals, to another Let's Fix Generals 0 Hour to make the best game ever. Okay, oh, sorry about that. Last video, we finished implementing the function match bundle. And it all works, so that's good. Okay, so next step. Now we could either clean up runner a little bit or start with the ASM matcher. So basically here in this function, there's a little bit of dirt, right? Let me see. Split into two functions. Process. I think this to do can be removed. Process PP. Yeah, so basically here, process ASM output. Yeah, I mean, we haven't been using this thing here, really. This is semi function. Okay, I think that this here, these functions, they should not be part of executable. Let's copy this and move it to runner. Dump function to fire. And take executable. Runner CPP. Okay, I think for starters, we need to make this static. Set up. Okay, that looks good. Okay. Range of bytes and outputs a format as though it were a single function. Addresses should be the absolute addresses. Okay. Move disassemble function and disassemble gas function out of executable class. say from executable to runner class. Okay, the next change, I would like to move these guys down. So we take these and move them down here. Move functions in runner.cpp. Let's compile first. Good. Is there anything else you would like to do? I mean, it's a bit... maybe I wonder if we should remove this. Dump function to fire. Yeah, I don't think we need this here anymore. Process ASM outputs. Yeah, okay. So I would say we delete if output fire if not output fire empty, then do this. Okay, let's do assert. Well, we say if not o dot output fire dot empty. Actually, we don't need this. This one already takes care of it. O dot output fire executable. Yeah. To return true, return false, delete all this. Then I think we can delete this guy here. Executable. I think we can move this down here. Consts. This should also be const. Okay. Puts. Okay. remove placeholder logic in runner from. Okay. Good. Next. I think now we are ready. ASM matcher. Good. Okay. Let's think about this. So we will have okay, I think for starters, we need ASM matcher.h. Then we need the ASM matcher.cpp. And we need the ASM matcher types.h and cpp. Then we go to our CMake list. CPP. Okay. Good. Good. So we have this ASM matcher data to store relevant types. Includes, oh boy. space unassemblize. Okay. Class to match ASM code, ASM texts, assembler, to compare assembler texts. Compare. Yeah. Class is a match. Okay, then next we go to runner. We remove this to do. I would say we move these guys here to ASM matcher types here. Includes array, includes string, includes vector. Well, we need to include function. Okay, include function. Includes function. Then we take this and put that here. Actually, this thing belongs more to runner, doesn't it? Yeah, it's only used here. Includes as a matcher types. Pairs a function for two executables. Okay. So our ASM matcher would effectively get hands on these things. The runner. The runner. So the runner currently. Yes. The runner currently builds these bundles. Includes ASM matcher types. Okay, let's see if it compiles. Okay, so far so good. Okay, so the ASM matcher. We will need to pass. We need to pass the bundle. This match bundles. I do wonder, does it need to be a member? That's a question. Does it need to be a member? Maybe. Maybe not. I already see a little bit of a problem with the design we currently have, and that is if we just want to reevaluate a certain thing. Like right now, it reads the PDB, and it basically just builds everything in steps, but it always builds the whole thing. You can't say, hey, just build me this one thing. Well, yeah, but I guess that's something to think about another time. Yeah, I mean, whether or not it's a performance problem is not really clear yet. I mean, for the small data we currently have, this is lightning fast. How it scales later needs to be tested, and if there will be issues with loading times, then we have to look at this. But I think the biggest cost is actually in the disassembly. So as long as we don't do the disassembly for all things at once, should be fine. Yeah, we have to worry about this later. I can't anticipate this right now. Because right now we build it to do everything on one go, right? We have command line and we pipe everything through, and it just does everything in one go. If we have a UI later, then we need to think about how we can do things more efficient if we need them to be more efficient. Like, let's say we recompile the PDB executable, and then use that, reload. Like, what do we need to reload then? Do we need to reload everything from the PDB? Yeah, don't need to worry about this too much right now. Okay, so we have public. Is a match default. Okay, so okay, so we will have a function like bool or void compare or I do actually wonder if ASM matcher is a good name. ASM matcher. Let's call it run comparison. Run comparison, and then we give it the function match bundle const bundle. Hold on. Bundles. Function match bundles. Bundles. Okay. Namespace unassemblize. Is a match run comparison. Okay. And in here we say, yeah, now it becomes interesting. Wait, before we continue here, let's hook it up in our runner. So basically here we do ASM match dot run comparison run comparison bundles match bundles includes ASM match. Okay, run comparison. Okay, so it's hooked up. On the run comparison, we probably also want function match bundle, a singular bundle. Yeah. Singular bundle. And this effectively calls for bundles, bundle const bundles run comparison bundle. Okay, so you can pass it either a single or multiples. Good. Okay. Good. Now we are ready to think about our ASM matcher. Good. So essentially in our bundle we have matches. Oh, actually we need more. Oh, I forgot things. So we also need to pass function I think we should create a new type. Struct function match function match definition function match collection. That's it. Collection. And this one contains function matches and function bundles because they belong together. So matches and bundles. Okay. And then in our runner, instead of having this, we create this here. FMC. Maybe that is okay. FMC. FMC matches. Okay, we have FMC. Well, FMC is a little bit of a lame name, isn't it? Maybe we can have better name. Bundles. 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 Good. All right. Okay, let's call this collection. Match collection. It's a bit long. Maybe it's okay. Let's see. Yeah, it's okay. Match collection. Good. Then run comparison. So you run comparison over everything. And if we invoke it on UI, we can selectively do this. Right? We need to pass match collection. So match collection. Match collection. Let's just call it collection. Collection. Run comparison. Bundles. Okay, and then we can also say function matches. Okay, so we need to be able to const function matches and bundle matches and bundle. Okay, so this would be let's also create a function for function matches and bundles plural. Bundles, bundles. And what is in the bundle? Matches, function match. And then we do another run comparison on function match, single match. There we go. Okay. Okay, so it gives us a lot of freedom to invoke it with different kind of things. Okay. Is a match. Huh? I just realized now here we have a different tab for some reason. Because we didn't save yet. I see. Okay, so here we do run comparison collection dot bundles collection dot matches collection dot bundles. There we go. Then next we do run comparison. This one here for bundles, run comparison matches. And then we have another one for matches, match. Oh no, that's wrong. Bundle dot matches. There we go. This index. Okay, for index T, E equals no E. Let's do index edx. And we run comparison matches edx. There we go. Okay. Okay, so this way we could pass different kind of arguments to run the comparison, but now the question is, okay, we will have a result. Yeah, okay, it makes sense. So we run the comparison against the data we set. So either a single function match or from a match bundle or from multiple bundles, these options. So multiple bundles. But this is a problem. Was it not? Basically, yeah, I think passing it this way is not very useful, because if we want to have an like this makes sense. This makes sense. But this not so much. Yeah, I think this should actually be part of here. So we have match collection dot bundles. But then we don't need really, like when I see this, we don't really need this collection thingy. Or do we? Doesn't hurt, I guess. Maybe we rename it to collection. Collection. Let's call it M collection. That reads kind of weird. Let's just call it collection then. Collection dot matches. Yeah, so basically we want to run in separate comparison for each, but this is also yeah, I think it's okay. Yeah. Bundle. Well, actually, maybe the matcher should be entirely operate on this level, just this. It doesn't know about bundles. It just knows about this. And everything else, like how you manage the bundles, is external. Okay, so in our ASM matcher, yeah, let's comment out this stuff and take this and comment out this as well. And in our runner, we put bundle matches. Is a matcher yeah, collection matches index match. So essentially the matcher operates on one function match, and then so you run the comparison, and then you can ask afterwards what the result is. Run comparison. Yeah. Okay, let's do it like this for now. Yeah. Okay, so the ASM matcher essentially doesn't really work with bundles, which I think is fair. Like it's externally handled. Maybe we think of something to do it with ASM matcher then. But for now, let's not worry about it too much. Yeah. Okay, I think this is fair. Okay, let's see if it compiles. Well, there's not much in it. There's not much in it. Good. Yeah, run comparison. What do we do here? So we have a match. It has a name. But we don't care about the name. We only care about functions. We have two functions. Yeah, two functions. Okay. That's how we do it. Let's look a little bit around. Good, so we have get instructions, begin address, end address. Okay, we don't care about address really. At least not now. Well, yeah, no. Yeah. Okay, so get instructions. Instruction data vector. Instruction data vector. Data vector 0. Oh, let's call it instructions 0. Instructions 1. What is the problem here? Const, of course. Okay, so we have instructions. In our instructions, we have, well, what do we have now? Okay, now we need to be smart. So we basically mostly look at text, right? text. This can take a while to figure out. Run comparison. So basically, we would like to get a report of what is identical and what is not. Maybe we first need to think about what do we actually want to get out of this comparison, right? Maybe we should start there. What is the what data would we like to get out of this? We would like to know what matches and what doesn't match, right? So we probably would need to have a so we would have a struct. We want to see left and right text where it's different and where it matches, right? This will be fun. That's interesting. But I think once we get into what we actually want and how we can get there, I think it will implement nicely. We just need to figure it out. We need to think about it well, yeah. So let's take our good time thinking about this. We have ASM text on the left and right. Some instructions are the same and some are different. Now, we would like to know what is different and what is the same. What kind of data would we then use for that? We need a record. Yeah, we need a Okay, we certainly would like to have a vector which we can just iterate line and entry by entry, and it would give us a top to bottom list of things that are different and are the same. But that would mean we need a data structure that can accommodate matches and differences. But I assume to describe matches and differences, there's different data needed. So I'm not sure how to do that. There's, of course, always the option of a STD variant, but using STD variant for this, I don't know. Well, we could. STD variant. So you could say struct ASM match struct ASM match. That would be 1. And then we have another struct ASM mismatch. Right? Mismatch. Okay. And in the match, there would be something like std string text, right? Text. Yeah, simple that. And then the ASM mismatch, it would say, what would it say? Oof. Yeah, ASM match, basically we just need to say we have a text, right? That's it. But std variants, std variant for this, I don't know, ASM match text. We can also use we can well, if you can keep ASM mismatch small, then I guess it would be fine. Otherwise, you could use inheritance. Yeah, but, ASM mismatch. Actually, text. Okay, I think here we also need std array address 64t to addresses. We need to say, let's look at our instruction. ASM match struct. We also need ASM label city string label. Yeah. Okay, so we filter out the labels into asm label. We filter out matching text with the text, and it will be, well, hold on, it won't be the same left and right. Not necessarily. Not necessarily. We also need std array string to text, because there can be differences with the with symbols when they have like location or unknown or these kind of things. Yeah. Text. Okay, but if they have different text in this regard, then there can still be a match. Yeah. Okay, so we got label, we got addresses, text. Okay, mismatch. What data do we need here? Mismatch. Mismatch. Well, mismatch also needs this stuff. Do we want to save anything else? We could also say, hold on, mismatch. Okay, in a mismatch, one side can also be an empty string, right? It doesn't have to be like one mismatching assembly line and that's it. But there can also be like, we have 5 lines on one side and then just one line on the other side. And then what happens is we have 5 ASM mismatches, but 4 of them would be empty on one side because it only has one text, right? So that would be valid, but that would be accommodated with this. We just have empty text, and I guess the address can also be empty. Well, from the prior address. Can be empty. Yeah, it can be empty then. Yeah. Okay, this will work. Yeah. Okay, this so far will work, I think. What about this jump len? Do we care? I mean, for comparison, we care, but do we care for printing? Hmm. I would say we create a copy of this thing. Let's do ASM symbol, and we remove this label thing. So we have ASM label, ASM symbol. Or ASM instruction. Yeah. So basically we split the instruction data into ASM label and ASM instruction, two separate pieces. Oh boy. Okay, and then we can put the ASM instruction here. Instructions. Instruction pair. Do the same here. Instruction pair. We do struct ASM mismatch detail. STD array. No. Mismatch detail. And 16. U and 16. Mismatch detail. Mismatch parts. Mismatch bits. Let's call this instruction mismatch bits. Bits representing position where presenting positions where instructions are mismatching. Okay. And then we would have here is a mismatch detail too. Detail pair. Okay. Yeah. And then we would have include variant. Struct ASM comparison results. And in here we would have a std vector and using elements equals std variant. So it can be either label ASM match or ASM mismatch. vector element instruction path. ASM comparison results. Oh boy, ASM comparison results. How do we call this? Let's call this lines. Line. Then maybe we can also have some simple is match or is matching. False. Yeah. Okay, let's see how big that variant is. Line. Oh, we can't really see. Well, if I put a line here, let's see. 128. Yeah. Yeah, it's pretty big. Why is it so big? Because 56 times 2 plus this thing here. Yeah. This is 4 bytes. What was it? 56? Hmm. 120 bytes. Yeah. Here it's 128 because of alignments. Okay, let's move these guys to the header. Or maybe even here. ASM instruction. Includes function. Function. ASM format. This type here. I don't like that it's basically a copy, partly a copy of the other structure. I wonder how we can consolidate this, but there's a little bit of a header problem here. Because this one includes function.h. Yeah, mismatch detail. Label, match, mismatch. Yeah, okay. Okay, I guess what we can do is we take this guy and we put it here into function. Here, ASM instruction. And then we put this guy here. like this. Ins label. This would now require a bunch of adjustments. ASM instruction. Maybe call this oh. This jump is okay. How about we rename this to instruction ASM instruction EX. Then we call this base. You can also do inheritance here, public, like this. Then we don't need to refactor anything. Yeah, that's good. We can delete this. Yeah. Then we rename this to ASM instruction vector. No. Instruction EX vector. There we go. Okay. Yeah. I think we can get started with this data. Yeah. Okay, so basically we'll have a private ASM comparison results. Results. I don't know, maybe it should just be a static function and return. Run compressor. Yeah, let's for now make it a static function and return this. I don't know if we actually need any members in this thing. Maybe not. I don't know. Results. Return results. Okay, let's see if it compiles for now. Doesn't. Variants. Oh. This is C++ 20. No. C++ 17. What's the problem? Oh, right. Include variants. There we go. Okay, so we have a data structure. Yeah, there is a variant inside. Maybe we should make this, yeah. There's a variant inside using line. Maybe we call this ASM line. Then we do it using ASM line vector lines. Let's do this initialized to 0. Okay. Yeah. Yeah. I think this data layout makes a lot of sense. So basically in this vector, we can then push either a label structure or ASM match structure or mismatch structure. Now these guys are quite large, but pretty much the same. This one is a bit smaller. Yeah. Yeah. Yeah, and then so when we have this information, let's say it's all implemented. So we have label mismatch match. Then we can iterate through our vector here. And we can check, there is a label. Then we can ignore, well, it's ignored anyway, yeah. But then we see ASM match. We know, so for displaying UI or printing into a text file, you can print the label, we can print the instruction pair. Well, if Basically, this information is the same as it's the same apart from this one here. It's the same information as this one, with the difference that it gives additional information whether it's a match or a mismatch, plus where some mismatch detail is. That's all it is. So we're just transforming ASM instruction EX to these three things and putting it in here. That's all it does. It takes our instruction data and puts it in here. But it's not straightforward to get this done because we need to look through the lines. Yeah. Okay, but this will be the next step. We need to look through the lines one by one and try to make sense of them as best as possible. Yeah. Okay. Okay. Then, yeah. Okay, we have a plan, but it is already looking promising. Yeah. Good. Then we will continue implementing this in the next session. I don't think we can do it now. It has been 1 hour 55. Yeah, I think it's a good time to stop it here. Yeah, we got quite some things done, but still a little bit more left to do. Well, I think once we got the ASM matcher done, we can then also print like a result from this. And then once that is done, we can get started on the UI pretty much. But I think it would be a great milestone if when the matcher is done and printing the matcher results, then I think we are golden. Yeah. Yeah. This sounds good to me. Yeah. All right. I think yeah, we can end it here. I hope you enjoyed. Yeah. I'm fully concentrated on the work and not on talking while working. So there's probably not much interesting coming out of my mouth as I talk, but it doesn't have to, right? As long as we make progress, that's all that matters. Only code matters at this point. It's not about education. It's not about, well, it is a bit about, well, it's about inspiration, maybe a little bit education. I guess if someone watches, and I guess, I don't know. Like, I didn't get any feedback. If someone would watch this in order to learn something, would he learn from this? I don't know. I guess it can help to see someone code, but it's hard to say. I think the best way to learn is to actually code yourself. Go at your own pace and try to figure out. What obviously helps is to have a mentor that helps you correct the mistakes and show you the way, right? Lead you away. Yeah. But on the other hand, yeah, I guess what also helps is reading good code, like looking at good code in the language that you want to learn and understand and follow. And yeah, like a good code gives you a good idea of what you should do, right? So look at large code bases, read through that. So that's probably a good idea. Having a mentor that reviews your code, obviously that's big. So yeah, because it's easy, like when just starting out or not so experienced, and it's super easy to make bad design decisions or like you lock yourself into bad habits eventually as well. Yeah, and there are always elegant solutions to how you can implement certain things. And like you won't like have everything super picture perfect, but there's always some way to simplify certain things, and if you can make a code simple, then that's always good. You should always strive for that. Simple, the less code you have, the better. If it's simple to read, even better. Yeah, keep things simple. I think here in our program we have done a few things a little bit too complicated. So for example, in PDB reader, we have too much information. Like this call, this checksum, this is all stuff we likely won't need. So we can delete a lot of stuff here. Yeah, it's too much. There's too much complexity here in what we have built actually. Even though it's already much simpler than what is in the PDB itself, right? But it's too much info. Like we can simplify this stuff as well. But I mean that's not a big deal, right? If you have too much data points, just remove some data points, right? If you don't need them. But yeah, clean codes, yeah, simple functions. I think it all has to start with data structures. Think about simple data structures. That's, I think, the most important. Yeah. Think about your data. Always. Think about what kind of data do you want? Like, you always have an input. Programming is all about transforming data. That's all it is. You have some inputs, you have some outputs. You do something with the data, and then you have some results. That's all it is. Always. It's always the same. Right? And you want to think how do I get from A to B? How do I transform my data? Do I just want to check it for something? Or do I want to transform it? So now in our case, we transform data, right? We take this thing here, this, and we transform it into these things here. Yeah. So that's all we do. Transform data. So I would say always think about data structures first, because then it also becomes clearer what you need to do. Once you know what your inputs and what your outputs are, then you just need to connect these with logic, right? That's all you do. Yeah. All right. I hope you enjoyed. I wish you a great day or night. Until next time. Goodbye.